Alright, today's topic is adding and subtracting with rational expressions. So, first thing we're going to do is a quick review. Go back to, I don't know when you learned this, 3rd grade, 4th grade, would be my guess. Someone gives you a problem like this. 2/5 plus 2/5 equals.
Why can't it just be that? Maybe
What is the first thing we look for when we add fractions, right? We look for a common denominator. These are both fifths. So the answer is going to be in fifths. And then we add the numerators. I'm going to write this out very deliberately because this is what you're going to have to do with rational expressions. 2 plus 2 is our new numerator. Then we try to actually simplify that further, and we can in this case by making it 4 fifths. What about this one? 1/6 plus 3/6. So we're looking at the same thing first. We have the same denominator. Do I want to reduce this? No, because then I would then have to multiply it by 3 to get the same denominator back. Right? So I want to first add, so I have 1 plus 3/6, and now I have 4/6, and now I'm going to look to see if I can reduce. Can I reduce this?
Yes.
Yes. That's 2/6. So reducing is the last step. And this is important when we transfer this to rational expressions. You're going to do that simplifying step last. Right? All that stuff that we learned last week about simplifying rational expressions. All right. So, what if we have something that looks a little bit more complicated? Something like this. 5/x plus 3/x. Well, this looks a little funny because our denominator is no longer a number.
But they're both the same.
But it is the same, right? X and x, those are the same number. So I would add this the same way that I added those fractions. 5 plus 3 over x. I think the easiest place to get tripped up is when you add, when you get to this like step of actually doing the adding. A lot of times people want to add the denominators. It's the same thing that happened in 3rd grade when you were learning this with fractions, most likely. You want to say like, oh, is that 2x or x squared or? No, it's just x. Right? We keep the same denominator. Okay. What about this one? 3/x plus 1 plus 10 over x plus 1. Now this denominator looks really weird. Right? Not only is it not a number, it's like got 2 parts to it. X plus 1. But it's still the same denominator. No matter how complex looking these get, as long as the denominators are the same, you can add your fractions. So I've got 3 plus 10, which is 13, over, what's my denominator? X plus 1. Wait, but I had x plus 1 here and here. Yeah, so that's why I have it here, right? I'm not combining the denominators, I'm only combining the numerators. It's very important. All right. So, let's do one from tonight's homework. how they'll look on your homework. Something like this. 5x over 12y cubed plus x plus 2y over 12y cubed. Alright, two fractions. I'm adding them. My first question is, do I have the same denominator? 12y cubed, 12y cubed. I do. Cool. So, I'm just going to combine these over that common denominator. And this is why at the beginning I was writing out 2 plus 2, 1 plus 3. Right? Because this may not be as obvious how these two numerators are going to combine. So just simply write out the first numerator, 5x, plus the second numerator, x plus 2y. Now, technically, there's a parentheses here, and there's a parentheses here. Because I'm adding my first numerator to my second numerator, right? I'm not adding 5x to x and then adding 2y. But in this case, does that matter? No, right? So because of the associative property of addition, I can just add these two and then leave that one over there. So I can add 5x plus x, which is 6x, and then leave the 2y over here, and then I have 12y cubed. And now just like with the fractions, right, the last step is to look for something that we can cancel from the top and the bottom. To do that, we're going to want to factor the top. So if we factor the top, we get 2 times 3x plus y over 12y cubed. And then we see, oh, 2 is a factor of the top. Boom. 2 is a factor of 12. So I can cancel that. And I end up with 3x plus y over, oops, oh, that's a y, over 6y cubed.
Can you cancel a y?
Is y a factor of the bottom?
No.
Of the bottom?
Yes.
Yeah. Is y a factor of the top?
No.
No. Right? I can't think of anything. So this is the question we want to ask. Y times what would equal 3x plus y? I can't think of anything. Right? Now, I mean, technically I can. Right? Well, this would be the same thing as 3x divided by y plus 1. But that seems more complicated to me. Then I'm going to end up with a fraction up in my numerator. I don't want to do that. Right? So what we're looking for is just a simple expression, a simple way of factoring, not something really convoluted in order to cancel out factors. And y is a term up here, but don't get terms confused with factors. You cannot cancel terms from the top with factors from the bottom. It has to be a factor of the top.
What about the 3 and 6?
So is 3 a factor of the top? 3 times what
Oh, no, it's not.
would equal 3x plus y? So again, I can think of something, x plus 1/3 y. But I don't really want to end up with fractions in my numerator. So I'm not going to do that. That's too convoluted. Another way to think about this is if I cancel a 3, I have to cancel it from every single term. So I have to cancel it here, here, which is the hard one, and here.
Are we going to get our test back today?
Probably not. All right. Oh. What am I doing? All right. Can I erase this? This only gets a little trickier if we have subtraction. So let me do kind of a simpler example first. If I had something like 3/5 minus 2/5. I'm going to do sort of a weird illustration here. We all know that 3/5 minus 2/5 is 1/5, right? But look, 3/5 minus 2/5 is the same as 3/5 minus 1 plus 1/5. Right? 2 is 1 plus 1. So that would be 3 minus 1 plus 1/5. So let's see, 3 minus 1 is 2 plus 1 is 3. Wait, 3/5 minus 2/5 is 3/5? Look, 3 minus 1 is 2, plus 1 is 3 again. What am I doing wrong?
My entire math is a lie.
You have to
We
add.
broke math.
You have to add the letter 1 first. 'Cause times
Math has been
So,
broken.
the key is to remember that this numerator is technically in parentheses, right? I'm subtracting this numerator. I'm not subtracting 1, I'm subtracting the whole numerator. So what property applies here? I have this negative in front of these parentheses.
times
This would, I would consider this the distributive property. And I'm doing it kind of silly, you're right, like we could just combine the 1 plus 1 to make 2 again. Because I'm making sort of a silly example because I think it makes it really obvious. And then when we see a more complex example, you'll know what to do. So I take the negative times the 1 and times the other one. Right? I have to subtract both of these 1s. So I actually have 3 minus 1 over 5, which is 1. Right? So instead of minus one of them and plus the other one, I'm subtracting both things. And that's Alright, we didn't break math. Math is still valid. We'll keep trying though.
I wonder if anyone's ever broken math.
Oh yeah, the first person who took a square root of a negative number, they totally broke math. All right, so I'm going to do another one from your homework. This is number 5. 6x minus 6 over 3x squared minus 14x plus 15 minus
What is it?
4.
14x plus 15?
Hold on, I'll step back in a second. Alright. So I have C2 fractions. I'm adding them. Well, I'm subtracting them, but same thing. And I look first at the denominator and I see the same thing twice. Awesome.
Are we gonna have any where there's not a constant denominator?
Not tonight. Alright, so I see the same thing twice, so I just simply combine the numerators. I'm going to do this very deliberately, minus 4. Now in this case there's only one thing in the denominator here. So this is the same as just minus 4. Like that. But I'm putting the parentheses so you remember. Subtract everything in that second denominator. Over 3x squared minus 14x plus 15. Oh, this is going to be fun. Alright, so 6x minus 6 minus 4 is 6x minus 10 over 3x 3x squared minus 14x plus 15. What do you think we should probably do now?
Factor.
Yeah. Probably need to factor the denominator to see if there's anything in common. Now, I'm thinking it'll be easier if I know what I'm looking for. So the top is 2 times 3x minus 5. Let's just assume that one of the factors of the bottom is 3x minus 5. Because I know there's not a 2 in this. So if something cancels, it's got to be this 3x minus 5. Well, if 3x minus 5 is one factor, the other factor has to be x minus 3. Because x times 3x is going to give me 3x squared. The minus 3 times the minus 5 will give me plus 15. But let's make sure that we also get the minus 14x. And we can do that by multiplying 3x times negative 3, which is negative 9, and negative 5 times x, which is negative 5x. So that's a total of negative 14x. So by starting with what I suspected to be the factor, I made this a lot easier, right? All I have to do is look at this and ask, what will it take to make this 3x into a 3x squared? The answer is x. Then I look at this one and I say, what will it take to make this negative 5 into a positive 15? The answer is negative 3. And then I just check to make sure that I actually get the negative 14x. Is it possible that I wouldn't?
Yeah.
Yeah, it's totally possible. This could have some other factor, right? It could be like 3x minus 1 and x plus, or x minus 15, right? It could be some totally different thing. But then I know that it's not going to cancel as well. So if I don't get this middle term back, then I'm not going to be able to cancel. I don't really have to factor them in that case. Anyway, in this case, I see that this factor here cancels with this factor here, and I end up with 2 over x minus 3. Let's say I asked you for the excluded values on this one. What would they be?
X cannot be 3, and X cannot be.
Yeah, 5 over 3 because of this thing that we canceled. All right. If you're taking a placement test or something like that, and they ask you to do a problem like this, write the excluded values no matter what. I know that I've told you guys in here, you only have to write them if I'm asking you for them. In general, you want to be safe rather than sorry, right? So if you're on a placement test, it's totally free response. You get to that answer. Last step is write your excluded values. Even if they didn't say, state the excluded values at the top. You still want to write them there with this type of problem. Okay. All right, let's do one more.
Wait, when are most placements? January.
It depends. A lot of schools have multiple dates. Okay. All right, let's look at this one. This one is also from your homework. Do I have the same denominator? Yes. So I'm going to start off by writing 2n minus 3. What am I going to write next?
Minus n plus 1.
Minus n plus 1. Right? Why plus 1? It says
Because
minus
the
1.
two negatives equal.
Yeah, I'm distributing this negative to both terms in the numerator. 2n minus 3 minus n plus 1. So now I'm going to combine my like terms. The 2n and the minus n makes n. The minus 3 and the plus 1 makes a minus 2 over n, n squared, minus 8n plus 12. Okay, my guess is that I'm going to be able to factor n minus 2 out of the bottom. Let's see.
N minus 6.
Would n minus 6 then give me the minus 8n? Yes, it would. So that works. These are factors of this. So then I can cancel the n minus 2, and I'm left with 1 over n minus 6. As long as n does not equal
6 or 2.
6 or 2. Make sure that that's on the board. Yeah. And that's it. We're done. Okay, questions about these?